Hi students, we'll see the problem. We have seen about what is hypothesis and what is testing the hypothesis, and we have also seen about the type of errors, type 1 and type 2 errors. Now we'll solve one problem. Suppose it is found that average weight of a potato was 50 grams and standard deviation was 5.1 gram nearly 5 years ago. We want to test that due to advancement in agricultural technology, the average weight of a potato has been increased. To test this, a random sample of 50 potatoes is taken and calculate the sample mean X as 52 grams. Describe the procedure to carry out this test. Okay, we'll start with the procedures, what we are going to do. So we'll start with the what and all is given to us. First, what is given to us is here we have given they have given about the mu naught, that is the population mean, as 50 grams in the question, and population standard deviation sigma equal to 5.1 grams, and sample size n equal to 50. I'll show the questions to you. So what and all is given to us is nothing but mu naught, that is 50 grams. This is our population mean, and population standard deviation, here standard deviation, right? Population standard deviation is 5.1 grams, that is sigma is 5.1 grams, and we on this 5 years since the previous one is given, and also they have taken the 50 potatoes, so size of the sample is 50 because sample has taken as 50 potatoes, so n is equal to 50, then sample mean x equal to 52 grams. So these are the details given to us. Using this detail, we have to now solve the sum. So the step 1, what we are going to do is nothing but we'll start, whatever all is given, we will write it down. First is, it is given about the mu naught. Okay, mu naught is nothing but 50 gram, and population standard deviation is 5.1 gram, and sample mean, okay, sorry, sample size is 50. Sample mean x bar is 52 grams. These are the details given to us. To carry out the above test, we have to follow the following steps. So for this, we want to follow the step 1. What will be our step 1? Okay, step 1 will be, we have to set up the null and alternative hypothesis. Okay, so in order to set the null and alternative hypothesis, we will first write it down our claim. What is our claim? Average weight of potato has increased. So this is what we have to our claim. Average weight of potato has increased. That is, mu is greater than 50. Okay, and its complement, what is the complement of this statement? Mu is lesser than or equal to 50. Where the equal to is there, here we are having equal to. So this will be our null hypothesis, because wherever equal to sign is there, that will be our null hypothesis, and this should be our alternative hypothesis. Understood? Has increased, average weight of potato has increased. Therefore, that is the reason we have taken mu is greater than 50, and complement also we have taken. Now, since complement contains the equality sign, okay, we have to take the complement as the null hypothesis and the claim as alternative hypothesis. The claim is given no here. This claim. This is our claim. We want to ultimately we want to claim this. So this will be our alternative. So this is our alternative hypothesis. Now, what we'll be writing? H naught. That is our null hypothesis. Mu is lesser than or equal to 50. Okay, what will be our alternative hypothesis? H1. Okay, this is our alternative hypothesis. H1 is greater than 50. Okay, this is our null hypothesis. Mu is less than or equal to 50, and this is your alternative hypothesis. Okay, we have seen that mu h naught is mu greater than or equal to 50, and also h1 is mu is greater than 50. Okay, and what is our theta? Theta is nothing but our population parameter. Here we are talking about the mean, right? Alternative hypothesis is here, it is right tailed. Okay, mu is greater than 50. This is our critical point, and this is our rejection region. Okay, this is our rejection region. This is our critical point. This is my mu. Okay, greater than 50. And this is what we are going to claim now. Here if you see, that is, it is a right-tailed hypothesis. Right side is there, no? Therefore, I will write it down here. Right-tailed. Okay, because it is on the right hand side. Okay, because it is on the right hand side, it is known as the right-tailed. Okay, our test is right-tailed. So we can say right-tailed hypothesis. Now we go to step 2. What is our step 2? After setting the null and alternative hypothesis, we fix the alpha. Okay. Okay, so after null and alternative hypothesis we have set, no? So we have to fix the alpha. So what is that alpha? Okay, why we are fixing alpha? It's quite simple. You can understand in this manner. That is, to what percent confident, to what confidence I'm going to fix this null hypothesis, confidence level. Okay, that is level of significance alpha. Suppose alpha equal to 0.01, that is 1% level. Okay, so why we are fixing alpha? The reason is we want to say that some hypothesis we are claiming, and to what percent we are claiming, to what percent to confidence, to what confidence I'm going to claim it. So this confidence level, suppose you want to tell some statement and you will be telling that to what confidence that statement is true. So I can say that 95% something is true or 99% something is true. Here we are talking about the 99%. Okay, so normally they use 95% and 99%. In standard we use. Next is the step 3. Step 3 talks about the now we have fixed the null hypothesis. Now we have to test it. Okay, test statistic. Statistic is what that is our sample. So we have to test the null hypothesis. So we are going to find the sample, and using the sample you are going to use all the statistics. Okay, and samples mean and all we are going to consider. That is not a statistic. Okay, sample statistic is nothing but statistic, that is we are talking about the samples mean minus value of the parameter under H naught. So we have assumed under H naught mu is what and all. That is our value of the parameter under H naught. Now standard error divided by standard error of statistic. Why we are dividing standard error of statistics is quite simple to understand, because whenever we take the sample, sure some error will be there, minute or whatever it is. So in order to nullify this, we are going to divide it, right? So T will be equal to, what is the difference between our sample mean and the population mean? Okay, if the difference is very less, means we are very closer to the reality. If the difference is too large, means we are away from the reality, right? So that is what the minus represents, the difference between the sample and the population. If the sample and population is difference between them is very big, that means we are very far away from the realistic. So this difference gives you the real scenario, and here we have fixed the level as 1%, that is 99% confidence level. 100 minus 1, that is 99% confidence level, and standard error is nothing but sigma by root n, right? As the size of the sample increases, sigma by root n will decrease. Variance means how much we are far away. That is known as a variance. Sigma is standard deviation, right? Square root of variance is the standard deviation. So that is why standard error is sigma by root n, right? Since the size is large, what we have taken the how many potatoes? 50 potatoes. That is greater than 30. 30 greater than 30 is known as law of large numbers, says that greater than 30 is sample size is large. Okay, since sample size is large, using the law of large numbers, so n equal to 50, which is greater than 30, right? So by central limit theorem, the sampling distribution of test statistic approximately follows standard normal distribution. So central limit theorem says that if the sample size is large, that is greater than 30, then whatever distribution it is following the normal distribution. Okay, standard normal distribution. So our sample size is large, no, more than 30. Therefore, all the distribution will follow the normal distribution, approximated to normal distribution. The last step 4 will be calculate the value of test statistics. Okay, on the basis of sample observations. We take some sample and we calculate this test statistic. Okay, and what is our T? X bar. X bar is given here as 52, right? X bar is what? 52, right here. X bar is 52. So 52 minus 50 here, okay, divided by sigma, that is 5.1 by root 50, that is nothing but 2 by 0.72. So answer will be 2.78. Now we have to see the Z table, and if this value is greater than the Z table value, we have to reject the null hypothesis. That we'll see in the next class.